Good evening, good afternoon, or good morning to all of you, depending on where you are. This is Megan Jones from ICEA, welcoming you to another one of ICEA's Tech Showcase webinars, where the companies behind the products that make your job easier get to show us their stuff. Today's webinar is sponsored by Palisade and features Rishi Prabhakar, a second-time ICEA presenter, coming at us live today from an actual gold mine. Rishi gave us another presentation late last year that's available on the ICEA website and on our YouTube channel in case you missed it. And today, Rishi's going to be walking us through getting your risk register right. Rishi?
Great, thank you very much. And in case people are wondering, yes, I am actually at a gold mine. And no, they don't give out samples. Yes, they're very, very fussy about that sort of thing. But, you know, you live and learn. So let's jump on in. Now, today's topic is risk registers. Now, everyone has some notion of risk events that could impact them, and you need to model them. For some of us, this will be your entire focus. For others, these shocks to our system are a smaller component of what we do, but they're all quite necessary. We're all very familiar with the future and the world itself being quite uncertain, and things that do happen to us aren't always things that we planned or aren't always necessary to complete our projects and programs and investments, but they happen to us anyway. The problem is, for us to be able to utilize our knowledge about these events, we need to model them appropriately. The good news is you have all the tools available to model these things appropriately. So why doesn't everyone just get this right? Okay, so modeling itself is a little bit of a skill, a little bit of an art form. Some models are very straightforward, some are super complicated. Risk registers can be very easy, but it turns out that most of the risk registers that I've met over the last 15 years of modeling them with clients and for clients have been either a little or a lot wrong. Now, what's wrong in a model? What could possibly be a mistake in a model? Well, a mistake in a model is that the data produced when you run a simulation doesn't actually represent data that is indistinguishable from a possible future. That's a whole bunch of words, but basically what it means is that if you want to say you have a model and you want to run a simulation to get information about your exposure, you have to be producing outcomes that you are actually exposed to. A classic example of a mistake, and it's one that I do thankfully see less and less these days, but it still definitely exists. It certainly exists in people's minds as a concept, and unfortunately sometimes still exists on their spreadsheets, is that we believe an event has a likelihood, let's say 10%. We think it'll cost $100. So simply put, we multiply those two things together and say, well, our risk amount is $10. Well, no, it's not. Nothing of any meaning or use to you is $10 in this case. If we think about this as a concept, we try and forget the numbers. Let's just talk about it. If something has a 10% chance of occurring, it has a 90% chance of not occurring. So there's a 10% chance that you will lose $100 in this case, and a 90% chance that you will lose nothing because the event didn't occur. So when exactly are you exposed to $10? You're not. Now, some people will try to argue that, but this is the expected value, and so it evens out and the highs and lows cancel, and all these sorts of things that sound okay, but simply aren't true, for the simple fact that you are never exposed to $10, and this particular event either happens once or it doesn't. You don't get to ride the highs and lows of this event. You will do your project or whatever this risk register is valid for once, because it's there once, and you will either pay $0 or $100. Knowing that maybe the expected value is 10 is of perhaps some academic use, but you are absolutely affected by the number $100 or 0. You're never affected by 10. Okay, and just I'll edit this live as we go. Another trick about this is, what if I have an event that I think is 1% likely, but it might cost $1,000? Well, of course, if I say that times that, I get $10 again. So as a framework, an item that could cost me $100 is given the same risked value or risked amount, allegedly, as something that could cost 1,000. I know it's less likely, but if I look at the impact to my business, I definitely don't think these two things are the same. So clearly there is a whole bunch of intuitive issues with this idea. So what's going on? What's the problem? I need to be able to model what will actually happen. Now, I do know this is a super simple situation. I do get that. But this basic idea is super simple. You need to model what will occur. And as your risks and world get more and more complicated, we need more and more sophisticated models to handle it. But we are always going back to that single fundamental basic idea. You need to have a spreadsheet that produces data of actual potential outcomes. So in this particular case, what's missing? What's missing is that the likelihood, if it exists, and more on that in a moment, if it exists, is a parameter of a function that will then be used in a model, as opposed to being used directly in the model. So here it's being used, turns out that's wrong. Here it's being used, this 10%, as a parameter in a Bernoulli distribution. Now the Bernoulli function, lovely little function, classic discrete distribution. It returns a 0 or a 1, 0 or a 1, with the probability that you allocate it. So in this case, it's a 0 with a 90% chance and a 1 with a 10% chance in every single iteration of a simulation. So when it's 0, this is the equivalent of the event didn't occur, and therefore the impact is 0. But if I were to randomly sample, we can see some parts of my spreadsheet are wearing away. If it's a 1, that means in this iteration or this possible future, the event did occur. Guess what it cost me? $100. Okay, so this model has now taken this knowledge that there's a 10% chance of something happening and it'll cost me $100, and produced an actual model where this cell here, got L5 here, this impact, is an actual model of what can happen. You see it, hopefully you can see that whirring away in front of you. Sometimes it's naught, in fact, quite often it's naught, but sometimes it's 100. It's never $10. Okay, so we've got a super simple situation there. The only source of variability is that the event will either happen or not. I model that variability using an appropriate probability distribution, and now my spreadsheet is actually returning outcomes that can happen. So in combination with other indirect and direct costs or inherent and contingent risks that I've got modeled, this cell can now be referenced by my sum function, whatever it might be, and it's actually giving me or producing for me actual total possible outcomes. Another mistake that I've seen, and I won't name names, won't name and shame, but I've even seen this in commercial software that's available, is that you take the likelihood and you say, okay, Rishi, that's fine. I still think it's 10% likely. You said that I've not included the uncertainty properly. No problem. Here's my low, mid, high, or 3-point estimate for the severity. And so what I do is multiply the likelihood by each of the parameters. Again, I can understand how people might think that this is reasonable, but if you sort of think a second time about it, clearly it's not. All I've done is said, look, I've got some numbers. How about I times them together? There is no more logic to it than that, and it turns out, of course, to be quite incorrect. So once again, the range of possibilities for this risk event are 0 or a value between 80 and 120. But if I multiply my parameters by 10%, I now have a range of possibilities between 8 and 12. Instead of having a single value that doesn't exist, now I've got a range of values that don't exist. It's the same problem, just shown in a different way. So it's great that we can think of parameters for our model, even though, just by the by, these aren't great parameters, and I'm pretty sure I talked about other or previous webinars, so I won't go through that again, but they're here now to keep it simple. It's great that you could think of that, but your knowledge has not been used appropriately. So whoever came up with this information knows that the only dollar amounts that you're exposed to are 0 or something between 80 and 120. But then this model structure is incorrectly bastardizing your knowledge and saying everything that can happen is something between 8 and 12. Between 8 and 12. So once again, if the model structure is incorrect, that should be enough for you to say that that's terrible and we need to fix it. But it's even more insidious than that, in that if the model structure isn't right, all of your knowledge is being wasted, essentially. The time you spend and the information you put into this model, which itself is probably correct because you're a subject matter expert, is simply not being used in the way that it's returning useful information. So when the model that you've got your great knowledge has gone into, but the model structure comes out with numbers between $8 and $12, even though it should be 0 or between 80 and 120, this is the reflection of you, but not really. So you're being punished because when this event actually occurs, it's never what the model said it was, even though you knew the right stuff. Same solution as before. We have the Bernoulli function referencing the 10%, and then the severity conditional on the event occurring is modeled appropriately. And now it is in fact the product of the frequency distribution and the severity distribution that is the true model of this input. So again, if I turn the random button on and spin it away, whenever the frequency is 0, in other words, it didn't happen, but you could technically say that's a frequency of 0, the impact is 0, regardless of what the severity spins up. That's just like it's just freewheeling there. But when the frequency is 1, then the impact is whatever the severity spins up in that particular iteration. So this impact cell is once again actually reflective of not only your knowledge, but the reality of that knowledge and producing actual data of what you're exposed to. Okay. Now let's extend this idea once again and say that we need to have the model structure correct or as reasonable as possible for us to be able to produce results that are worth reporting, that we should be able to stand behind confidently. Okay. This doesn't look like much of a model. It's just a collection of question marks. The most common flaw that I find in risk registers, and look, when you hear what it is, you'll know why, and probably a lot of the 85 attendees online right now have this in their risk concept, in their risk framework, in their registers probably, and that is the erroneous idea that everything has a likelihood. Initially, I sound like a madman for telling you that not everything has a likelihood. Of course, that everything's got a chance. Okay, well, we need to be careful with our language, and we need to really think about what it is that we are trying to do. We are trying to model what we are exposed to, as in actual possible outcomes. I'd like you to think of, I'm in a gold mine right now, and so accidents, like on most works or any work site, accidents are something that is of interest to them. They want to avoid accidents. If I ask their safety expert, what is the likelihood of accidents? There is not actually a reasonable way of answering that question. What am I actually asking when I ask the expert, what's the likelihood of accidents? Because what could happen? There could be, let's say we're just talking about this year, there could be no accidents. There could be 1 accident. There could be 2 accidents. There could be 3 accidents. There could be 4 accidents. So when I say what's the likelihood, what am I actually asking? The likelihood of exactly one or more, the likelihood of an even number of accidents. I'm being facetious now, but you realize that it's super easy to have words come out of your mouth like, just tell me the likelihood or the chance of this event. It takes a little bit more effort for you to say, oh, does that make sense? Have I given enough information in my question that it's a useful question? When I get an answer, what will I do with it? Will I do something meaningful with it? And if I ask someone, what's the likelihood of an event, if that event could occur more than once, from the start, I've set this process up to fail. The likelihood is the correct parameter to use if your event could only possibly occur once in the framework of your model. There might be, let's say, a access through private property line item, and you've currently budgeted that the farmer will allow you to drive to use their their roads to get to a remote site. Maybe you're looking at power lines or something, or they refuse. So the risk event is that you are denied easy access through private property, and you have to go the long way around. Maybe you have to use helicopters, I don't know, something. But it's more expensive and you're certainly not what you planned for. So the risk event is a genuine one-off, and you will allocate to that or estimate for that the likelihood that it occurs. Great. The vast majority of events that I've seen in people's risk registers, again, over the last 15 years of looking at them, are things that can occur more than once. Accidents, flood events, wet weather, machine downtime. What's the probability of downtime in one of the crushes in this mine over this year? The answer is 100%. It's guaranteed to happen. But that doesn't help me model. That doesn't help me model anything. So instead, what I need to do is to say, what would help me create a model that produces reasonable results of what I am actually exposed to? So this is a real fundamental issue, and I've only been talking about it for a couple of minutes. It can often take a long time for this idea to really sink in. If you've got it straight away, fantastic. But I want to create a useful model. That's the only skin in the game that I've got. I don't work for the company that owns the risk register. I'm not managing these risks. I'm helping them model it. I want to help them model it reasonably. Forcing people to only use a likelihood, poor choice. It guarantees that you cannot apply your subject matter expertise to the model. When in doubt, think of something like accidents or machine breakdowns and realize that there's just no concept of likelihood associated with that. So what likelihood is there, or what are we going to replace with that? I've already used the word frequency. And previously when I used the word frequency, it seemed a little bit heavy-handed. I'm trying to be a bit more exotic than I need to. The only frequencies in that previous event were defined as being 0 or 1. But the fact is it is a frequency, and that is in fact the key. If I model frequency and the only possibilities are 0 or 1, you better tell me the likelihood of that event, and I'll use a Bernoulli function. But if the possibilities are beyond just 0 and 1, like lightning strikes, accidents, external weather events, could be any like machine failures, all these are really obvious and great examples, then my frequency will not be defined by a likelihood. Instead, the most straightforward approach to use, of course there are others, but the most straightforward approach is to say, what is the statistical mean frequency for the time period that I'm looking at? So let's pretend this is an event that I'm looking at and my model is annual. So this is next year's risk register. What's a mean of 2.5 mean? Clearly I can't get 2.5 of these events occurring. I can't have 2.5 motor vehicle accidents. But maybe over the last 10 years, I've had 25 accidents. Well, that works out to an average of 2.5. Maybe if I'm looking at storms and I go to the BOMs, or the Bureau of Meteorology, and they let me know data over the last 30 years or something like that, and it says that the average number of storms of a magnitude that I'm interested in, so things that could actually cause me damage, the average is 12.6 per year. That's perfectly acceptable. And you can see that there are reasonable and robust ways of producing that kind of information. Obviously, in the end, we might just end up estimating. So you say, oh, look, what's the average going to be? And just note that that's different to how many will happen, because how many can only be an integer, but the mean could be fractional, some decimal. So instead of saying everything has a likelihood, because it doesn't, I say everything has a frequency. I mean, that's still not quite true. There are things that don't have a frequency. So what we're focusing on today is things that can be counted. So it's got a frequency. Can the frequency be more than 1? If so, I need the mean. Can the frequency be no more than 1? Well, in that case, I need a likelihood. The function that I'm going to use if I have a potentially multiple frequency is a Poisson. And here's an example of the Poisson. It's still a frequency, so only non-negative integers are allowed, but there's no upper limit. I could put one in. If for some reason I knew technically you can't get more than 6 of these, I can truncate. Like, that's pretty cool. But if I just ignore that for now or take that away, the actual outcomes are 0 or 1 or 2 or 3 or 4 or 5 and so on. And each of them have their own likelihood. But that's each of them. And I haven't had to define an infinite number of likelihoods to be able to build this Poisson. I just gave it the expected value, this lambda bad boy over here. And that then created for me what is probably a reasonable distribution, or in the least, a reasonable starting point. So that's modeled my frequency. If I go back to not understanding things, if I just allocate a likelihood to something, to a risk event, therefore it can only happen or not, what would I then do about the severity? So if I've allocated a likelihood incorrectly to an event that could occur more than once, how on earth do I come up with these dollars? Do I come up with the dollars like a low, mid, high for maybe the low cases? What'll happen if it maybe happens once, and the mid case if it happens 3 times, and the high case if it happens 5 times? Well, then I'm ignoring what happens if it happens 6, 7, or 8, or 9, or 10 times. It's also super difficult for me to come up with a single distribution that represents the impact of multiple events. A single probability distribution that magically looks like 1 and 2 and 3 and 4 and so on, numbers of events. A subject matter expert cannot, in any reasonable way, come up with the severity parameters if I've got the whole likelihood frequency thing wrong. In the little blurb that I put together about what I would be talking about, it was about making a model, not just that is technically correct, because that, a lot of people don't care about that, but let's make it helpful to the user. Let's make sure that we're doing things easier. So once we establish this frequency component of our model, this distribution, whether it's the Bernoulli, the Poisson, or something else, it actually determines how many times something happens. So what's left over for the severity or the consequence are parameters for something happening. It's so important, I'm going to write it in caps, exactly once. What is the severity of this risk event if it happens exactly once? That's so much easier for you to think about, so much easier for it to parameterize. You potentially have data based on individual observations for worksite accidents, for vehicular accidents on site. You'll definitely have things like downtime figures for your machine breakdowns and so on. You absolutely will find it easier to model the consequence or severity of an event where it occurs exactly once than some range of number of times. The reason the parameters previously, we didn't even have to worry about it, was because that by definition, these were the severity parameters of the event if it occurred exactly once. We just didn't think about it because that was part of the construction, that if we have a likelihood the event was only occurring once. Now we're explicitly saying, does it occur only once and no more, or could it occur more times? Well, now I definitely need to know or be aware of the fact that how many times it happens is taken care of with the frequency. Therefore, the severity will be the severity per event. So I've actually made your job easier by giving you a more accurate model. So that's 2 wins. That's 2 rights making a right squared, if you like. It's double right. It's extra good. But there's a little bit of a trick here. If I think about an event that can occur more than once, if it was to happen twice, say, each time it happens, it will be of a different magnitude. So I've created a distribution of the severity or consequence of this event if it occurs once. So each time it happens, it will or should actually be a sample from this distribution. And for however many times it happens, I need to sample that many times and add them up. So let's say this is accidents. I'll pretend that I've got still got caps lock on. That's how angry I am. Accidents. A mean of 2.5. Let's say this is for next year. The impact of each accident has been modeled in this way. So if I want to know the actual impact of accidents, I need to add up all of the accidents that I'm exposed to. Okay, so I know the frequency of the accidents. I know the severity of each accident. And the process that combines them is called compounding. And compounding says, you tell me the frequency distribution. And you shouldn't be doing that. Let's go try and show you a picture of this. Sorry, just proof that it's live. This should just go straight to that distribution. Sorry, I'm having a window problem. I will attempt to, I know what, I'll just build this live. Okay, so compound. Compound says, what is the frequency distribution? This is how many events could occur in every iteration. Then it says, what is the distribution of each individual event? Well, that's the severity that I just created. Now I have a distribution. It looks funny, but if you think about it, it is logically sound for the actual impact of this event type. So you can see this first spike here. What's that? Well, that's a spike at 0. And 0 means there were no accidents, so the impact was nothing. This next spike you can see is centered around 100. What does that represent? Well, if you have 1 accident, the impact will be something around 100. This next spike centered around 200. What's that? Well, that's the scenario where there were 2 accidents, and it's centered around 200, but spread as it would be with 2 samples being added up. So you can kind of look at these numbers and go, look, theoretically, it could be something between 160 and 240. And the same for 300, 400, 500. So this multimodal shape is in fact an accurate model of the impact of this line item. If I run a simulation, the risk compound function will sample the frequency. Whatever that number is, it will then take that many samples from the severity or consequence distribution, add them up, and say, here is the total impact of that line item. And you can see that it is modeled soundly. And as I've already described, the elements feeding into it are logically sound. And especially this thing about allowing for multiple frequencies now, I've actually made your job easier in terms of the severity or consequence parameters are now easier to get. Okay, they're now easier to build. All right. So, no, I shouldn't have cancelled that. That's all right. I'll put it back in there. Why not? Compound. There's my compound function. Bam. Easy. Okay. Now, I mentioned before to you that like not every model has a frequency. We might save that for another webinar in terms of fancy things that I haven't covered so far in my webinars. The majority of your risk events have a frequency, just as the majority of your direct cost items are either lump sum amounts or they have a quantity and a rate. But there are exceptions to both of those things. There are exceptions to modeling direct costs and exceptions to modeling indirect costs as well. But as a basic framework, this is the framework that we should have. You identify your risk events. That's your expertise. You then identify, is this an event that can only happen once? Or could it happen multiple times? If it can only happen once, I need you to tell me the probability that it will happen. If it can happen more than once, I need you to tell me the expected value. Here's a 3.7, and note here's a 0.4. So I would expect this distribution to not happen. And there's nearly a 70% chance that, 67% chance of 0. But it could be 1 or 2, or if I just change my x-axis here just to make it a little bit easier to see, let's go out to, say that's a 5. So it could be 0 or 1 or 2 or 3 or 4 or 5, but they're really, really unlikely, as you can see. Why are they so unlikely? Because I said the average was 0.4. So probably nothing will happen, maybe 1. There's a chance of 2. What's the probability of exactly 2? It's about 5%, 5.4%. There's less than a 1% chance that there will be 3 or more. Cool, well that suits the idea that I think that the expected value is less than 1. Based on that logic, you then choose the appropriate probability distribution. In all cases, the severity should be built as the severity for a single instance or occurrence of the event. And then I use compound to model all of them. Okay, and then eventually I have my total, and I know that it's been built in quite a reasonable way. Okay, so apart from exceptions, this is a framework that will cover almost all of your risk modeling needs. Okay, hopefully I've been able to explain why we do it. And you can see that when the framework is set up appropriately, it actually makes your job easier. It's not just easier, it is a better reflection of your knowledge. Therefore, the data that comes out of this will be better insofar as being more realistic. And we are simply taking what you already know and doing something more reasonable with it. Great, so I will leave my little risk register expose there and throw it over to you guys to see if you have any questions about any aspect of risk register modeling that you would like me to address right now.
Bang, look at that, one right away. Rishi, do you want to take it?
I would love to, but I'm not seeing anything in my chat window, sorry. Maybe I can't see
All right.
the question. Sorry, yeah.
Sure.
So my apologies, and if someone did ask a question during that, yeah, nothing, just on a technical note, nothing came up in my thing to indicate that a question had been asked. So I'm sorry, I wasn't ignoring you. I just didn't get a notification, my apologies.
The good news is we hadn't received any as yet. Is compounding affected if the underlying distributions are a mixture of discrete and continuous distributions? That's our question.
Okay, good question, good question. So compounding, if I take a look at this risk compound function here, it references these two cells, a frequency cell and a severity cell. Now, what we, I guess, can take from that is that the contents of each of those cells, the frequency distribution and severity distribution, could be as simple as what I've shown here, one discrete function, one continuous function, but they literally can be anything, and I really mean that. So this severity, for instance, as you say, it might have needed to be a combination of continuous and discrete functions, or some other formula. That's totally fine. At-risk just needs to know what it is to be able to calculate it. The frequency, now that's another interesting one. You might model the frequency maybe of like a large frequency, something that has a lot of potential outcomes, and you might model that as a continuous function. In this particular instance, at-risk will round a fractional frequency returned value to the nearest integer and then perform that many samples. So really there's not really much in the way of limitations on what these things could be, because the compound will always return you an integer for this, and then this calculation is simply whatever that calculation is. So at-risk should be able to do that for you.
All right. Are you able, have you seen the questions yet?
I'm sorry, I'm not getting any pop-up here. My apologies, yeah.
No, don't be sorry, it happens all the time. Like you said, this is a live show. So somebody asks where this at-risk toolkit is available.
How about I go here and say Palisade.com. So the company I work for is Palisade, and you will see in there splash at the start of this webinar. So that's us, and we make this software called At-Risk. We do other things as well, but in this space, the most commonly used tool will be At-Risk, and that's everything that you've seen today is inside that software. And you can see that it is an add-in to Excel, and that's the At-Risk ribbon that is across the top here that I've been playing with a little bit.
Okay, we have one that sort of looks like a threefer. So let's see. Richard, if you could unmute yourself, I'm about to unmute you so you can ask your question.
How do I unmute?
You did it just like that. Perfect.
So
Are you there,
am
Richard? Oh, there
am I unmuted?
You are unmuted. Go for it.
Thank you. Sorry for being such a dope. So in the last box, Rishi, fabulous presentation, by the way. You have summed risks 1 through 3. Does this implicitly assume that these risks are not correlated?
Very good question. Yes, it has, but in a funny way of saying it, it only assumes it because I haven't told it to correlate. So for instance, if I thought that these two risks, maybe they're both impacted by similar weather conditions, or they're both impacted by similar, maybe they're both to do with different types of maintenance breakdowns. And so if the weather is, whether it's particularly windy or it's particularly wet or something that means that the frequency of these events should have been correlated, well, then I can simply correlate them. And that correlation will then flow into the calculation. Okay, so the sum itself is just going to sum up these numbers, whatever they are. And if they happen to include components that are correlated, then that will quite necessarily be included in, I guess, the information of that sum. Okay, now in terms of correlation, the frequencies can be correlated because they happen prior to compounding. These severity distributions are simply indicative distributions of what needs to be sampled. They in a way, they don't exist. They have to be on the spreadsheet somewhere, but they're not an actual outcome that can be correlated directly. Now, with that said, there are fancy ways of building your model such that you can, in fact, correlate the entire risk. So this sum would include these risks being correlated at this level, but it's an extra step of complexity. But in a simplistic way, any of your frequencies could be correlated, be it with matrices or copulas, And then you would know that the sum there is therefore more realistic because the relationship of the propensity of these events to occur has been included.
Terrific, thank you, Rishi. While you're there and while I'm here, can I just ask you this question? The premise is, I work in a Mac environment. I use Microsoft Excel on a Mac.
Mm-hmm.
Does at-risk work in the Mac world?
No with a but, yes with an if. So if you do nothing, it won't work because at-risk is expecting to be in a Windows environment. So if you use things like, what are they called, parallels, that there are assorted Windows emulators you can use that you can run Excel on your Mac, but it thinks it's a Windows environment. That's how it will work. For some more specific details, again, if you just go to our website, palisade.com, there's a knowledge base there, and obviously it's one of the articles that's been there for a very long time, is I've got a Mac, how do I get at-risk to work? And so it can work, but you do have to do something to get it to work.
Thank you very much.
No problem at all, Richard.
All right. After Richard, we got another question. I think I'll try to ask this one. If the frequency is 0, why is there an impact?
Very good. Now, one of the tricks is, and one of the tricks of spreadsheet modeling when we have probabilistic models is, what am I looking at? Okay, so you might be looking here and saying, but the frequency is 0, why is the compound returning a value? The first and most important thing to note is that you're not looking at a simulation. Okay, so there is no simulated data point where the frequency is 0 and we actually get an outcome. If you think about, like, not that I'm encouraging gambling, but if you were at a casino, when the roulette wheel isn't spinning, the ball is on a number. Okay, when you when you're not throwing the dice at a craps table, the dice in someone's hand has numbers on top. That's the equivalent of these things. They're just some numbers that happen to be on top because Excel always returns a value. Okay. The trick will be is during a simulation, and I've just turned the random mode on now. So now you're actually looking at a live model. Whenever the frequency is 0, the impact will have to be 0. Okay. So what's happened is there's a viewing, I guess, subtlety or nuance to probabilistic modeling, which says that because this is all volatile, it's really tricky to understand what you're looking at when you're not running a simulation. And that's just a matter of the various viewing settings that are available in at-risk. It can be tricky, but they have to show something. Essentially, they have to show something, and the compound function by construction will attempt to show an estimate of its expected value. Okay, whereas my frequencies here, they're free to show an actual potential outcome. So this, I know it's a bit sort of tricky and maybe even annoying, doesn't correspond to this with the settings that I have. But if I'm in random mode, and this is actually how the model will run, you can see they do always correspond. Okay, it's just that it's tricky to show something that's got an infinite number of outcomes and always have it be returning something logical for you on the spreadsheet in front of you. Okay, so well picked up that you could see that looked like a bit of an anomaly. They said that's just a trick of the viewing settings.
Outstanding. Okay, we had one question come in, but it looks like you handled it in the answering of the last question, so that one we can skip for now. Sorry if I got quiet there. Are today's examples available in the software tool or within a tutorial on the Palisade website?
So this particular little workbook is not, but I can make that available via yourself, Megan.
I'll be happy to. I'll be happy to post this on ICSA too.
Sure.
And I will chat for just a moment while, so we have time for anybody to come up with any more questions. Oh wait, we have one more. Can I use a distribution as an input to the Bernoulli distribution? My likelihoods are expressed as a range of percentages.
Okay, so there's a little bit of a trick here, and I know like we don't necessarily have a lot of time, but there is a big philosophical question that just got asked, and people don't really realize that it was a big philosophical question. And here it is. If you are not confident of likelihood, do you have a likelihood that is a probability distribution or not? Now, at a very technical level, the Bernoulli function references a cell. As long as that cell returns a percentage or something from 0 to 1, the software will work. But I'll leave you with this idea. I would never do that. The reason I would never do that is if you make the probability of something a variable, essentially you are in a position where you're basically unable to interpret the simulation data that comes out. And here's why. Each iteration of a simulation isn't actually consecutive time periods. Each iteration is the same period over and over again with some random variation. The probability of an event occurring simply is some number from 0 to 1. It shouldn't change from one iteration to the next. Now, if there's some logical reason why the likelihood of an event would change, as opposed to we are simply uncertain of the estimate of that parameter, then I guess you could model it. But there is a philosophical issue that the probability of an event, whether you know it or not, is a fixed number. And in fact, the randomness or the unknownness that we think about is actually the frequency that spins up. So it's a bit of a cliche can of worms there. But just something to consider is that people do have variable probabilities in their models, but I've not encountered a situation where really they should. There are other techniques you can use in the software to help understand how important your lack of confidence in your estimate is. But that's different to saying that in each iteration, the likelihood of the event changes. So because that model assumption is changing each iteration, can I really put all that data together and describe an output in that way? Okay, so I can't really say too much more because it's actually a big philosophical argument that we could have, but I'd leave that as something for you to think about.
Awesome, and you guys are good job, everybody on listening. You're just firing the questions away. Just compounding include the ability to model concatenated events, such as if event A does occur within the event, then event B has a non-zero frequency to occur.
Okay, so if I've understood the question correctly, I think that that's not a question of the compound itself. It will behave how you want it to. What you would do is include that logic over here in the frequencies. So I could have, for example, this risk, instead of just being a 0, it could be if this is, greater than, or if this equals 1, because that's a yes, no, then it's, there's going to be, sorry, well, I'll just put this together. So if this equals 1, then this is going to be a Poisson distribution, but not just the regular one, it's going to be at least 1. So how about I throw in here if I've got to spell it correctly, a risk truncate function with a lower limit of 1. So this would be a logic that says if this event occurs, then this other event will occur at least once. But if it doesn't, then it might occur more than once, it might occur 0 times. So I think that the logic you're talking about would be built in because it's a functional relationship as opposed to a random sort of correlation dependency. I would literally force that relationship so that it does exactly what I want it to do.
We got a cool, makes sense, thanks follow up to that one. So I think you did. I think you nailed that. And then I think so 10 minutes left. We still have time for a few more questions if people still have them. Would it be worthwhile to use a Monte Carlo simulation to model the possibility of these variable probabilities?
Look, to be honest, I'm not quite sure what that question means. So as a technique, Monte Carlo simulation is simply, let's randomly sample the different possibilities that we're exposed to. And that's like a broad description of it. But what the spreadsheet actually represents to you is, of course, completely up to you. So the software can sample anything. What we just always need to be careful of is if we get into too many orders of modeling, so second order modeling and so on, where we're saying either I'll have variable parameters that are varying and so on, just make sure you know the logic of what you're trying to do, and that when you look at your data, you understand the assumptions that have gone into that data so you know how to interpret it. That's like a broad rule for anyone doing any sort of modeling. But the notion of simulating is just there's a range of possibilities and I want to understand them. I know the rules of all of the games, if you like, all of the cells, the inputs, the variables. I, of course, just don't know exactly what's going to happen. So we create probability distributions for them and sample them. And that can simply be applied to any. But if someone wants to simulate, randomly sample a likelihood, I would always want to think carefully about that logic, because usually, as I mentioned before, usually sampling a likelihood doesn't produce data that we can readily interpret, because it's not clear what the universe logic is at that moment.
This next question is actually about the answer to your most recent, the answer you just answered. The example you just showed is perhaps a causal relationship rather than a correlation, such as if event A happens, then events B and C have a greater probability of happening or not.
Sorry, Megan, could you repeat that, please?
Sure, and I may actually turn this over to the asker, because I hope I'm doing it justice. The example you just showed is perhaps a causal relationship rather than a correlation. Example, if event A happens, then events B and C have a greater probability of happening or not.
Mm-hmm. Yeah, that's right. So I did build in a causal relationship. The relationship that you build, and you notice that I used Excel formulas for it, unless we're going to actually use correlation, like as in this form of correlation, matrix correlation or copulars, then when we talk about relationships, they're going to be functional. So you can build in whatever the logic is that you require. For instance, if I have, okay, let's make this one simpler. Let's say you're actually going to be 40%, so you can be a Bernoulli, okay? So I've got a Bernoulli there, yes, no, and a Bernoulli here, yes, no. This parameter equals if this equals 1, no, not plus 1, equals 1, then it is 60%, otherwise it's 40%. So there is, rather than being causal on the frequency, it's now causal on the probability. So if this event happens, which is only 25% likely, this event actually becomes 60% likely to occur. Else, if this didn't happen, then this event is only 40% likely to occur. I think that's the sort of thing you're talking about, and clearly you can do it, and at-risk will sample as is, and that may be a logical approach. Note here that the likelihood, while it changes, isn't a random variable. It's not being randomly sampled between 40 and 60% or something. There is a distinct logic. So it takes a value under some condition or conditional on something else. The probability is different, but it is fixed outcomes as opposed to a random spread. So this would be perfectly acceptable, I think, and I think that's what you're referring to.
Excellent. Okay, so we got one more that might be our last, unless somebody brings another one to us. Does the risk compound approach work where costs and risks are profiled over time? Or would I be looking at a distinct risk lines for every year in which they could occur?
Great. So the chronology of the model essentially determines what it is you need to put into it. So a compound simply says, here is the frequency for whatever time period this cell is relevant for, and here is the severity for that time as appropriate to that time period. So if this was my whole risk register, then it's basically life of project modeling. But I could of course have one column per time period and have the next 10 years and have 10 compounds for each line item representing their impact across each of those years. And then I would get yearly sum cost information as well. But that's a choice you make about the structure of the underlying model. Compound has no time component to it, so it's not forced to be daily, weekly, monthly, annual, anything. You simply pick the appropriate parameters to represent whatever the time period is of that function, and you can have this function placed wherever you want in your workbook. So you set up your workbook for the time, in the time frame or chronologically how it's going to be useful for you, and then you simply put the appropriate distributions appropriately parameterized wherever you need them to go.
Perfect. And with a thanks, that answered my question. I think we can close it up for today. Thank you all for being such an engaged and actively engaged audience. Thank you to Palisade for making today's webinar happen, and thanks to Rishi for being able to present for us today. We'll put the spreadsheet up on the ICEAonline.com/tech showcase webinar. I'm sorry, tech showcase website in the morning. A quick note though, it may not, is this correct to say it may not work unless you actually have the the at-risk extension, or will it work?
That's correct. I'll send a version that can be opened in native Excel, but obviously
Okay.
none of the formulas and so on will be able to be simulated or anything without at risk.
Fair enough. Well, with that, do you want to have any closing words before we say goodbye to everyone?
No, I'd just like to thank everyone for coming on board and asking some pretty cool questions. Hopefully you got something out of that session, and I'll probably see you all again online at some point in the future.
I look forward to it. It's a pleasure to have you present for us, and I hope you do so again. Thanks again, everyone. Thanks again, Palisade. Everyone have a good rest of your day. Stay safe and sane out there. Be good to each other, and we'll see you all again soon.